simple, very elegant, does not need an intermediary, takes care of the double spend problem because every transaction which is being put into a block has to be first of all confirmed by one person. That is then validated by everybody else, all other nodes, right? So everything is decentralized. This data, this blockchain data, each node working on the network will have it. So if you log off today and log on tomorrow, when you log on tomorrow, your client will update itself from one of the neighboring nodes. So there is no central repository. Each node is a repository. It's completely decentralized. Right? So that's the whole idea of proof of work and the whole idea of using Bitcoins as a cryptocurrency. Now there are certain disadvantages to this also. So the first disadvantage is the difficulty level has increased so much that you need to have really expensive computers first of all, and computers that take up a lot of electricity to do this whole proof of work, mining and things like that. So they are saying, studies are saying that by 2020, one Bitcoin, like even mining one Bitcoin, will take up as much electricity as the average American household. And all the nodes in the network who are mining for Bitcoins are going to consume as much electricity as Denmark. That is how computationally intensive I'm talking about. That is the kind of electricity cost to this system. Right? So that is one disadvantage. There is this whole electricity cost that is going up. The other thing is, with the requirement also becoming so intensive, with the computational requirement becoming intensive, the whole mining is becoming more and more concentrated. Now there are people who are setting up mining farms, and a lot of these farms are coming up in places like China, in really cold places, because first of all these kind of computers need to cool off, so they're coming up in cold places, and they're coming up next to hydroelectricity projects, where they're getting power very cheap from the government. So what's happening is, unfortunately, the system is leading to a huge concentration of mining power being centered in one country, or in one region of that country. And the problem with this is, see, this whole concept of decentralized peer-to-peer transactions is based on an algorithm called the Byzantine generals problem, right? So what is the Byzantine generals problem? Imagine there is a group of Byzantine commanders, okay, who surrounded an enemy city and want to attack that city. Now, all these commanders are equal, they're peers. There is no chain of command, they're all peers. Now, these commanders have to send messages to each other on how to coordinate the strategy and come up with the best strategy for attacking the city. But one or more of the commanders in that group are corrupt commanders. And if they get the message, they may not relay the message faithfully, they may subvert the message. So the whole problem of how do you still account, how do you come up with an algorithm which can still take care of one or two bad actors in the system. So that was the algorithm which inspired Satoshi Nakamoto to come up with this white paper. So he saw that there's already an answer to this problem, where you can have an algorithm that can work on a trustless, intermediary-less basis, right? And for somebody to still overcome this algorithm, he would need to have 51% of the computing power of the entire network. But now, so the idea was with a decentralized network, nobody's going to have that kind of a computational power. But unfortunately, with this kind of concentration happening, there may be a situation where a few people may be able to hold 51%. In fact, security groups are saying they have done statistical modeling which says that you don't even need 51% power. Even if you have 30% of the power of the network, you can still do it. So tomorrow there is no saying. Somebody may acquire enough power to either do, basically what will happen is, there are honest nodes mining and creating blocks, attaching them to the chain. Imagine there are a bunch of guys who are bad actors. These guys can go back to blocks, reverse transactions, do double spend, and because they have so much of the computing power, they can create a chain that is going to be longer than the chains created by the honest nodes. And because the algorithm says the longest chain is what works, automatically this could become the chain, the default chain. That's the problem. The other problem is there's something called as distributed denial of service attack, where multiple compromised systems can target one particular node and prevent that node from doing its job. So the problem with proof of work, some people say, is because of this kind of concentration possibly happening, it could lead to this kind of situation. Obviously, the counter argument is people there investing in so much resources and things, to do this will not obviously want to do it, because the minute you support the system, the value of the Bitcoin itself comes down. Now, if I'm spending so much on equipment and time and resources just to do this, and if I'm going to lose out Bitcoins, so I'm not going to do that. So that's the counter argument. So time will tell how this is going to, pan out. So that is the second thing. The third probably challenge about Bitcoin, this one is something from an economic viewpoint, and this is what I believe in personally. I may be wrong here, but I feel now the problem with Bitcoin is Satoshi Nakamoto said you will have only 21 million Bitcoins mined, right? No more, no less. Now, irrespective of how the products, how the overall output, global output grows, these are going to be the only Bitcoins that are going to be there. The problem with having this kind of fixed supply of money is it can be deflationary. It's not inflationary, it could be deflationary. What is deflation? Deflation is where the price, the value of the money today is not as strong as tomorrow. It could be stronger tomorrow because the price of goods go down tomorrow. It's the opposite of inflation. Inflation is the price of goods go up tomorrow, so my $100 today is not the same $100 tomorrow. It's worth less than 100. But in deflation, it's the opposite. If my 100 today is it could get me 200 rupees worth of stuff tomorrow, I'm not going to spend that $100 today. I'm going to hold it. And I'm going to wait for prices to go down and then spend it. And that's a possibility with the Bitcoin. Because it's deflationary, what is happening is the medium of exchange role. Remember I told you, right? Money is playing two roles. One is the medium of exchange, two is store of value. The medium of exchange role is coming down and the store of value role kind of goes up, So Bitcoin doesn't become a money kind of thing per se. It becomes an asset class that people just invest and keep to themselves. So if that happens, how do you then, solve for it? So these are some of the challenges that I see with the system. Nevertheless, there's a huge community of nodes working, mining, day in, day out. There's a Bitcoin core group which is also monitoring the whole process, coming up with tweaks and things like that. The other challenge is the transaction speed. So the network sets a limit of 7 transactions per second. 7 Bitcoin transactions per second is the limit. Tomorrow they are thinking of lifting it in future. Actually, in reality, it's not even 7 transactions. I think there's about 3 transactions per second happening right now. Contrast this with the Visa. With the Visa, network, where they process 2,000 transactions per second. And Visa claims to have a peak capacity of 56,000 transactions per second. Where is 7 transactions and where is 56,000? Right? But like I said, the community is working on ways. There's this technology called SegWit. Maybe you guys can read up on that, where they're looking at trying to increase the transaction times, transaction speeds. But the trade-off is with increased transaction speeds, the block sizes may grow larger. And if the block size grows larger, the size of the entire blockchain database grows larger. So those are some of the trade-offs that the community is trying to kind of figure out and solve and things like that. In the meanwhile, what has happened is there's been a bunch of people looking at this and they said, look, this is a great system, but it has its limitations, it has its challenges. How can we work across these limitations? And now we have a lot of alternative coins, alternative cryptocurrencies, who are working on different kind of consensus mechanisms. So the most famous among them is now called proof of stake. And the most famous blockchain which is working on this proof of stake mechanism is the Ethereum blockchain. Right? So Ethereum has not moved to that yet fully. But what Ethereum is doing is, basically they are saying, instead of having proof of work, where each person has to spend so much on computing power, consume electricity, etc., 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 what we'll do is, they're not miners now. These days the nodes are called forgers. A forger will get to the node, he will sign up to be a forger. He will have to put a certain amount of Ethereum, of Ether, which is the cryptocurrency of Ethereum. So he will have to put up a certain amount of Ether as a deposit. And the larger amount of, the more the Ether he puts up as deposit, the more the chances of him being the one to validate a block. How does it work in proof of work? The guy with the maximum computation power has a greater chance of validating the block. With proof of stake, the guy putting up the maximum amount of money, stake, has a larger chance of validating a block. Now obviously, proof of stake means there is already money. If I'm already putting money, where is the mining happening? So in the Ethereum protocol, it's called Casper. All the money is going to be mined upfront itself. And and I don't know how the people get the money, but the money is already there. And I put the money, I validate the block. What is my economic incentive to validate the block? In proof of work, I was earning money, right? I was mining bitcoins into the system. Here, if the money is already being mined, what am I getting? I'm only getting the service, the transaction fees of the transactions happening in that. So that is how the proof of stake works. But the advantage is, it is not computationally intensive. You don't need to spend so much on computing power. And the second greater advantage that they claim is, because I am putting out so much money into the system, if I am acting against the system, I stand to lose my own money. So pure self-interest will stop me from executing a distributed denial of service attack or any other kind of attack on the system. So that's the whole thinking. But the problem is, see now the Ethereum, the guys when they came up with it, the creators called Vitalik Buterin, he wrote a lot of white papers. There's this decentralized autonomous organization. Basically, there is a company where they thought, let's run this company itself as a decentralized company and let's just base it on the Ethereum. Right? So a lot of these guys said, look, this is a great blockchain. Now Ethereum blockchain also has something called as a Turing completeness. So it's a Turing complete blockchain. What that means is, it allows you to build any kind of computer application on top of the blockchain. So unlike the Bitcoin blockchain, which is specifically limited to cryptocurrency as a use case, and Ethereum is Turing complete, you can build any kind of application. It could be cryptocurrency, it could be smart contracts, it could be anything. But the problem with this kind of sophistication is, there are larger chances for errors. And there was actually a bug in the Ethereum code which allowed somebody to siphon away $50 million worth of Ether last year. So, a lot of work has to happen on that front also. So when you look at something like that, you probably think that, tried and tested algorithms are like better and simpler. So that's kind of the inflection point where the community is. There are certain people who still swear by proof of work. There are people who swear by proof of stake, and they say, look, if the Bitcoin blockchain is a calculator, the Ethereum blockchain is a smartphone. So a lot of schools of thought over there, and now obviously we have other consortiums coming in. Banks, global banks have established a consortium called the R3CE, where they're trying to figure out use cases for the financial sector. IBM and a bunch of other companies have come up with a consortium called the Hyperledger project. So a lot of stuff happening around the world. But till today, the largest in terms of users or nodes still remains the Bitcoin blockchain. Right? So that's kind of where it is right now. Now, in terms of so use cases, right? So Bitcoin, cryptocurrency, okay, done. Now, obviously, people are talking about the underlying, tech behind the Bitcoin, the blockchain itself, and that's I think the reason why a lot of you are here also is because of that. You are more interested in the blockchain itself, the technology, the architecture itself, right? So, a lot of people are trying a lot of things. See, personally, my caveat or my thing is, I think 9 out of 10 of these initiatives happening right now will die a quiet death. Because a lot of the use cases I am seeing personally in the industry don't even need a blockchain. People are just force-fitting the blockchain and saying that, hey, we can now do this on the blockchain. So, in terms of the evolution of the ecosystem, we are probably where the internet was in the mid-90s, right? So that's kind of where we are. And if you look at the internet, how did that evolve? There was the infrastructure, the base infrastructure, then there was the middleware, then there were the end-user applications, right? I kind of see this also evolving the same way, not necessarily linearly, but it will happen in parallel, iteratively. So the only thing is, I still think we are a long, these are still very early days. So probably over the next 2-3 years is where you will see this maturing, at least the infrastructure, the base infrastructure in terms of the blockchains will mature, the middleware matures, and then people start building end user applications. So what are some of the use cases that I've been reading about? So obviously financial services, remittances. So remittance is one space where a lot of people are working with blockchains. So how does remittance work, right? So if I have to send money to, let's say, my family let's say I'm working in the US and I want to send money to my family in India, I will go to the bank in the US, my bank in the US, who will have a correspondent bank either in the US or in India. The correspondent bank does the transfer. Then there is a counterparty correspondent bank in India, which is then tied up to my recipient bank in India. So although, upfront, the transaction is happening immediately, the settlement is actually happening over 4 to 5 days. Now with the blockchain, where everything is happening instantaneously, not just the front-end transaction, but maybe the settlement can also happen a lot quicker. Right? So remittance is one place where people are looking at how to apply this. In fact, as part of our fund, we've in fact been talking to startups who are working in this space in Bangalore itself. So that is definitely one use case that I see happening. Financial services, yes, banks are all working, as Raghu was saying, bank chain consortium. So the thing with banking is, if you even look at payments, right? So even a Visa payment, like a Visa card payment, right? When I go to a merchant and I make the payment on my card, the transaction front end happens immediately, but the clearing takes time. It takes 3 days, it takes 4 days. That technology is still way back in the 60s. So now banks are looking at how can we use blockchain technology to speed up those kind of settlements also. And when you have interbank transactions happening, there are clearing houses which are doing this clearing, and settlement. Can we use the blockchain to disintermediate these clearing houses and let that happen between banks directly from one bank to another bank, right? Securities trading. Securities clearing also happens over a period of T+1, T+2 days. Can we use blockchain to make that happen instantaneously? Right? So that is in financial services space. Smart contracts. Smart contracts is another space where a lot of talk happening, lot of promise there, especially with blockchains like Ethereum coming up. What is a smart contract? It's basically just programmable logic. It's a contract where I'm saying, hey, if event A happens, then you make sure event B also happens. Right? So let's say, for example, insurance. If there is a calamity or something that happens, smart contract will say immediately make the payout, provided certain conditions are satisfied. Or let's say, for example, Internet of Things. Tomorrow, my car could be programmed into a smart contract, saying that, hey, has this guy paid his insurance? Only if he's paid his insurance on time, the car should start. Things like that. So smart contracts is one more area where there's a lot of action happening. Immutability. So what is one of the biggest advantages of the blockchain? It's immutability. Right? Once I have published a block of transactions, once all my other peers in the network have verified those blocks, becomes part of the blockchain, you cannot reverse that. It is virtually impossible. Like I said, you would probably need 51% of the networking power to be able to reverse that transaction. So once a transaction is entered onto the blockchain, it's pretty much immutable. Now where can we put this immutability to use? Land records, for example, especially in India, right? With all kinds of nonsense that happens. Imagine if there's something like this, a solution like this where everything is upfront, everything is transparent, and you know for sure that, if this guy is showing the sale deed, the blockchain verifies it, it is his sale deed. Art paintings, for example, provenance. So what is provenance? Origin. How do you trace the origin of the art painting, right? So you can have a blockchain which verifies the entire trail of ownership of that particular painting. So you know that this is not a fake, right? The diamond industry, in fact, there's a startup called Everledger which is doing exactly this for diamonds. Every diamond it is certifying and putting it on the blockchain, and you can rest assured that yes, if it's there on the blockchain, this is the provenance, this is the origin of the diamond. Right? IBM is actually working with Walmart. As he was saying, Alibaba was doing this, sorry? Supply chain management, exactly. IBM is working with Walmart on supply chain management. How? Let's say, for example, there's a swine flu outbreak, right? Now, Walmart sources from pig farms all over the country in the US, right? Now, in the old system, they're not sure where the pig is actually coming from, where the meat is coming from. So they say it's come from that region, so they shut down the entire region. Now, if I'm able to track this down to one particular farm in that region, I only have to shut down that farm. I don't have to shut down the rest of the region. Imagine the savings in cost in supply chain, right? So immutability can, again, that immutability characteristic, so many use cases because of that. And in future, you're going to have all kinds of decentralized apps here. So what is a decentralized app? Or what is a D-app? It's an app where you don't have any centralized repository or data warehouse or anything like that. So that's already there. The Bitcoin client is your decentralized app because that data is stored across multiple nodes. There is no one single point that anybody can attack. Right? Especially now we've been reading about all this ransomware and operations and whatnot being targeted. Imagine if this kind of data had to be completely decentralized. There is no single point for anybody to attack. There is no single weak point. There is no single choke point. Right? So one is that. Two, decentralized apps can completely disintermediate certain intermediaries. For example, Uber. Take Uber as an example. What is it valued at? 60 billion, 70 billion, right? Why is it being valued so much? Because of all the data it has. Imagine tomorrow with the Internet of Things, if you could book a car, it's a self-driving car, the car comes by itself, you make the ride, you make the payment, everything goes onto the blockchain. And you make the payment in a cryptocurrency. There is no need for any intermediary. like an Uber or an Airbnb. Data. Today the most valuable thing, it's the most valuable resource in the world, right? Operations is just making money on data. Tomorrow with the blockchain, you can sandbox or black box your data into one box and you can only release whatever data you want to release. Insurer wants certain information, release only what is relevant to that guy. Your doctor wants certain information, release what is relevant to that guy. Right? So it could be the era of small data, not big data, where you are in complete control of your data. Right? But the thing is, a lot of these things still work in progress, very, very early days. Like I said, maybe 9 out of 10 or 19 out of